In morgansbyers' mind, he sees an electromagnetic perpetual motion planetary ecosystem. Just imagine deep beneath the forest floor lies a hidden world, a world of intricate connections. This is the realm of mycelium. Mycelium is a network of fungal threads. It weaves its way through the soil, connecting trees and plants. These networks are essential for forest health. They act as communication pathways. Trees use them to share resources. They can even warn each other of danger. Imagine a mother tree sending nutrients to her seedlings through this network, or a dying tree bequeathing its energy to its neighbors. Mycelium networks are complex, they are adaptable, and they play a vital role in the forest ecosystem. These networks demonstrate the power of interconnectedness in nature. They remind us that even beneath the surface, life finds a way to communicate and thrive. We often think of communication as something we humans do with words or gestures. But nature has its own ways of sending messages. One of these is through electromagnetic communication. Electromagnetic waves are all around us. They travel through the air and even through solid objects. Light is an example of an electromagnetic wave, so are radio waves and X-rays. These waves carry energy and information. Living organisms can both emit and detect electromagnetic waves. This allows for communication on a subtle level. For instance, some animals use Earth's magnetic field to navigate. Others communicate through bioluminescence, emitting light to attract mates or ward off predators. Mycelium networks share striking similarities with electrical circuits. They both involve the flow of energy and information through a complex network. In an electrical circuit, electrons flow through wires. In a mycelium network, nutrients and chemical signals flow through the fungal threads. These networks are incredibly efficient. They can direct resources to where they are needed most. A tree under attack by insects can send out a chemical distress signal through the mycelium. This signal alerts other trees to the danger. They can then mount their defenses. The flow of energy through these networks is a delicate dance. It highlights the interconnectedness of the forest ecosystem. It reminds us that nature is a web of relationships where every organism plays a role. Nature is a master of harnessing energy. Consider the awe-inspiring power of a lightning storm, or the strange beauty of a brinacle, a finger of ice that descends from sea ice, freezing everything in its path. Lightning is a dramatic display of electrical discharge. It occurs when there is an imbalance of electrical charge between the clouds and the ground. Brinicles, on the other hand, form through a process called supercooling. Salt is expelled from freezing seawater, creating a plume of cold, dense brine that sinks and freezes the surrounding water. These phenomena, though seemingly disparate, highlight the incredible forces at play in the natural world. While we may never be able to fully control these forces, understanding them could inspire new ways to generate and manage energy. While a perpetual motion machine may be scientifically impossible, our planet offers a compelling example of a system in constant flux powered by external energy from the sun and internal energy from its core. This is the Gaia hypothesis, which views Earth as a self-regulating system. The Earth's atmosphere, oceans and land masses are in constant interaction. They exchange energy and matter in a complex dance that maintains the conditions necessary for life. Heat from the sun drives weather patterns, ocean currents, and the water cycle. The Earth's magnetic field, generated deep within the planet's core, acts as a shield against harmful solar radiation. Volcanic activity, though destructive on a local scale, plays a vital role in regulating the planet's temperature over geological timescales.
The interconnectedness we see in nature, from mycelium networks to the global ecosystem, raises profound questions about the nature of consciousness. If a forest can communicate and adapt through a network of fungi, what does this tell us about the origins of intelligence? Some scientists believe that consciousness is not limited to brains. They argue that it may be an emergent property of complex systems. In this view, consciousness arises from the interactions between individual components, whether they be neurons in a brain or trees in a forest. The interconnectedness of the natural world suggests that intelligence may have evolved in response to the challenges of survival in a constantly changing environment. By sharing information and resources, organisms increase their chances of survival.
For millennia, humans have looked to nature for inspiration. Biomimicry takes this inspiration a step further. It seeks to solve human challenges by emulating nature's designs and processes. We can see examples of biomimicry all around us. Velcro was inspired by the tiny hooks on burrs. The streamlined shape of bullet trains was inspired by the beak of the kingfisher bird. And scientists are studying the structure of spider silk to develop new materials that are both strong and lightweight. By studying how nature solves problems, we can develop more sustainable and efficient technologies. We can also gain a deeper appreciation for the ingenuity and resilience of the natural world.
The concept of symbiosis, where different organisms live together in mutually beneficial relationships, offers a powerful model for a more sustainable future. Just as trees and fungi have co-evolved to form mutually beneficial partnerships, humans can learn to live in greater harmony with the natural world. This requires a shift in perspective. We must move away from the idea of humans as separate from nature and embrace a more holistic worldview. We are part of the web of life, and our actions have consequences for the entire planet. By embracing sustainable practices such as renewable energy, regenerative agriculture, and circular economies, we can create a future where humans and nature thrive together.
The natural world is full of wonders yet to be discovered. From the intricate workings of the human brain to the vastness of space, there is still so much we don't know. But this is what makes science so exciting. It is an ongoing journey of discovery. By studying the natural world, we not only gain knowledge, but also cultivate a sense of awe and wonder. We are reminded of our place in the universe and the interconnectedness of all things. And we are inspired to protect and preserve the planet for future generations. The quest to understand nature is a journey without end, but it is a journey worth taking, for in unraveling nature's mysteries, we also learn more about ourselves and our place in the universe.